Hi, Assalamualaikum. My name is Muhammad Zaini bin Muhammad Yusri. My metric number is 045745. I'm from DTMM.
Okay, my name is Muhammad Hairul Akmal bin Zabidin. My metric number is 045191 and from DTMM.
My name is Muhammad Mizambi Hermal, number metric 045717 from DTMM.
My name is Muhammad Amirul Hakimi bin Muhammad Nazri. My metric number is 045566.
My name is Muhammad Fathi bin Mustaring. My matrix number 045005 and I'm from DTMM.
Linux is one popular version of Unix operation system. It is open source as its source code is freely available. So, Linux has three component operating system primarily. First, kernel. It's responsible for all major activities of operating system. Kernel provide the required abstraction to hide low-level hardware details to system or application programs. Second, system library. The functionalities of the operation system and do not require module code access right. Number three is system utility. System utility programs are responsible to specialize individual level tasks. So the basic Linux operating system. So first, portable. Software can work and different types of hardware in same way. Support the installation on any kind of hardware platform. Number two, open source. Linux source code is fully available and is community based on development project. Number three, multi-users. Multi-users can access system resources like RAM, memory, application program at the same time. Multi-programming. Linux is multi-programming system. Multiple application can run in one time. So number five, hierarchy file system. Standard disk file structure in which system file user file are arrayed. Next, shell. Shell used to execute the command, various type of operation, call application, program, and so on. And next, security. Security like password protection, controller access specific file, or encryption of. So we look the layer of Linux system architecture. For first, hardware, including RAM, HDD, CPU, and so on. Next, kernel. It is the core component operating system interact directly with hardware, provide low-level service upper layer components. Next, shell. And interface to kernel, hiding complexity of kernel function from user, the shell take command from the user and execute the kernel function. And lastly, utilities. Utilities program that provide the user most of the functionalities of an operation system.
Okay, next we're going to process scheduling. In Linux 2.4, the kernel use is NON scheduler. They have three scheduler class. Normal priority is 100 to 139, which round robin priority is 0 to 99. Fixed able, which is first in first out, is 0 to 99, favor a lower priorities. Priority of that go up begin as they use CPU, and priority of interactive thread go down boost. In version 2.6, the kernel use is NO1 scheduler. The completely phased scheduler CFS is a process scheduler which was merged into 2.6. It handles CPU resource allocation for executing process and aims to maximize overall CPU utilization while also maximizing interactive performance. CFS is a replacement for the earlier O1 scheduler. The Linux CFS scheduler provides an efficient algorithm for selecting which task to run next. Each run-able task is placed in a red-black tree. A balanced binary search tree whose key is based on the value v runtime. In this tree, at the left branch is the smaller value, while at the right branch is the large value from the v runtime value.
Next, we go to Linux synchronization or process synchronization. So, in process synchronization, Linux provides semaphore, spin lock, and read-write versions of both. So we're gonna go through semaphore and spin lock. So semaphore in Linux, there are two types of semaphore. The first one is binary and the second one is normal semaphore or counting semaphore. In the first case, value of semaphore may be only 1 or 0. In the second case, value of semaphore any non-negative number. If the value of semaphore is greater than 1, it is called as counting semaphore and it allows to acquire a lock to more than one process. This allows us to keep record of a variable resource. When spin lock allow to hold a lock only on one task. Next, we go through the spin lock in Linux. The spin lock is a lower level synchronization mechanism which in simple words represent as variable which can be two state. First state is acquired and second one is released. Each process which want to acquire a spin lock must write a value which represents spin lock acquired state to this variable and write spin lock release state to the variable. If a process try to execute code which is protected by spin lock, it will be locked while a process which hold this lock will release it.
Okay, next I want to talk about how Linux OS handle a deadlock. Before that, I want to explain what is deadlock all about. Deadlock is a situation where a set of process is waiting for an event that only another process in the set can cause. As an example, we got two processes in this particular time snapshot, and that is P1 and P2, and also we got resource 1 and resource 2. Resource 1 have been initialized to process 1, while resource 2 has been initialized to process 2. Deadlock can be happen when P1 try to request resource that process 2 have been hold, and a process 2 want to request resource 1 that process 1 hold. P1 had to wait until P2 release R2, and P2 also need to wait P1 to release R1 in order to access it. There is three ways to handle deadlock if it occurs. One is deadlock prevention and avoidance. Second is deadlock detection and recovery, and the third one is ignoring all deadlock. For first method, deadlock prevention, this method will not allow the system to enter into deadlock state by avoiding at least one out of the four conditions below. One is mature execution, no preemption, hold and wait, and circular wait. Deadlock avoidance is a method where it using banker algorithm to allocate resource by testing all the requests made by process for resource and check for its state and grant what the state after it granting the request system. Second is deadlock detection and recovery. In this approach, OS does not prevent deadlock, but it's allow the deadlocks, but it will detect any deadlocks occur and try to recover into a safe state using their own techniques. Okay, the third one is ignoring the deadlock. In this approach, it assumes deadlock never occur in the system. If it ever occur, it will let another application to cater this problem. Out of the three methods used to handle deadlock just now, Linux OS use the third method as a way to handle deadlock inside the system. This is because ignoring deadlock ever occur in the state is the easiest and the cheapest way out of three methods just now. This because deadlock prevention avoidance and deadlock detection and recovery much more effective in terms of resource utilization inside the system. Besides certain operating system like Linux, deadlock is rarely happen inside the system, and the cost to manage the deadlock is far exceed the benefit.
I will talk about the Linux file and directory structure. If we are coming from Windows, the Linux file system structure can be particularly different from Windows. The C drive and drive letters are gone, replaced by a backslash and cryptic sounding directories. Okay, this is a release of Linux directories. Number 1 is for backslash on the root, Every single file and directory starts from the root directory. Only root user has right privilege under this directory. Please note that /root is root user's home directories, which is not same as / only. Okay, number 2 is /bin. This is for user binaries. It contains binaries executables. Common Linux commands you need to use in single user modes located under this directory. Commands used by all the users of the system are located here. Okay. Number 3 is /sb. It's for system binaries. Just like /bin, /sb also contains binaries executables, but Linux commands located under this directory are used typically by system administrator for system maintenance purpose. Number 4, /etc is for configuration files. It contains configuration files required by all programs. This also contains startup and shutdowns, shell scripts used to start or stop individual's program. Number 5, /dev is for device files. It contains device files. These include terminal device, USB or any device attached to the system. And number 6 is /proc. It's for process information. It contains information about system process. This is pseudo file. System contains information about running process. Number 7 is /var. It's for variable file. var stands for variable file. Content of the file that are expected to grow can be found under this directory. Number 8 is for /tmt, temporary files. Directory that contain temporary files created by system and user. Files under this directory are deleted when systems are rebooted. Number 9 is /usr. It's for user programs. Contains binaries, libraries, documentation, and source code for second level program. Number 10, /home. It's for home directories. Home directories for all users to store their personal file. For example, /home John. Number 11, /boot. It's for bootloader files. Contains bootloader related files. Number 12 is /lib. It's for system libraries. Contains library file that supports the binaries located under /bin and /sb. Number 13 is /opt. It's for optional add-on applications. OPT stands for optionals. Contain add-on application from individual vendor. Add-on applications should be installed under either /opt or /opt subdirectory. Number 14 is /mnt. It's for mounts directory. Temporary mounts directory where system admin can mount file system. Number 15 is /media. It's for removable media devices. Temporary mount directory for removable devices. For example, /media /0 for 0. Okay. And the last is number 16, /srv. It's for service data. SRV stands for service. It contains server-specific services related data. For example, /srv /cvs contains CVS related data. Okay, that's all. Thank you.